Welcome back, learners. So in the previous lecture, so we have completed our design, that is the basic designs of all the columns by making 6 to 7 column numbers. Okay, by making 6 to 7 column groups, so we have made our complete one step of design. So now today let us finalize our entire design of the columns. Okay, yes, now you can see here that for this column number 53, 36, 72 on which a load of 550 kilonewton is acting, so I am taking the final shorter dimension as 1.3 and final longer dimension as 1.6 and my overall depth of the footing as 350 mm. Okay, yes, the final overall depth of the footing, and you can see that punching shear stress, so it is 1.2, permissible shear stress is 1.7, so therefore it is safe. Whereas in one way shear it is permissible shear stress is 0.38, this is 0.87. Okay, so almost it is also safe. So if you have the safe in the two-way punching shear, it is more than sufficient, because it is the most critical way of failure. So if you are protecting the column from the two-way punching shear, two-way shear or the punching shear, so then we can say that your footing is completely safe. Okay, so now once this is done, I am just going to give the final dimension in feet, because in the outside everybody will speaks in terms of the feet and inches, so therefore let us get the final values in feet and inches. So my shorter dimension of the footing, it is giving 4.25, I can make it to 4.3. okay, 4.3 feet. Okay, then the longer dimension I can make it to 5.3. okay, I can make it to 5.3. then the final depth of the footing I can make it to 1.2 feet. okay, I can make it to 1.2 feet, and my final inches I can make it to 3.70 is there, I can make it to 4 inch, because in practicality, so giving the spacing of less than 4 inches is very difficult, because when you give the spacing of less than 4 inches, then the aggregates will not pass through the reinforcement, so therefore what will happen, proper vibration will not occur. So therefore we never go to the spacing less than 4 inches, we maintain a minimum spacing of 4 inches. So therefore I am maintaining the 4 inch spacing, and these three also I will be maintaining this color only. Okay, yes, so therefore your first column design is done. Okay, so this is done. Now when I go to the second column, you can see that the same values are there, therefore I can here give 1.3 only, and I can give 1.6 only. Okay, so I can give these values only here, because the same are there. Okay, because the where there is a change is, there is a change in the column number. Okay, there is a change in the column number. So therefore I am getting my effective thickness as 165. Okay, so when I am giving 165, it is not able to pass, so therefore let us here make as 300 mm only. Okay, so I am making 300 mm, so therefore I can make this as my 350, and keep it in mind, students, that the maximum pressure, this critical section also I am supposed to change according to that. So the bending moment will change. Okay, then the factored critical section anyhow I have not changed, so effective thickness, so then percentage of steel, diameter of the bar used, right? So make sure that you are supposed to change the critical section, supposed to change A0 and B0. Okay, so therefore I am changing my A0 also, I am changing my B0 also. Okay, A0, B0, right? So this is no issues. Then here also I am supposed to change this distance D, I am supposed to change, right? The shear force, no issues. Okay, shear force, no issues. So this shear stress, okay, no issues. This 100 AST by BD, that is an value which can be again calculated. So then permissible shear stress also no issues. So therefore I am supposed to change, keep it in mind. I'm supposed to change the critical section. Okay, I'm supposed to change the critical section. Okay, so if you want, you can do this one, critical section. Then I'm supposed to change A0 and B0. Then I'm supposed to change this one, and this one. These three I'm supposed to change in the every one. So therefore this will be my final dimensions. So let us check what will happen to your two-way shear. You can see 1.25, 1.3 is there. Okay, 1.22, 1.37, 1.25, 1.3. So therefore I may have to increase little bit of column depth. So I can make it to 325, right? So when I make it 325, you can see it is 1.25 and 1.2. So therefore it is safe. Okay, so therefore I can make this as safe. Then what about your one-way shear? 0.4 and this is 0.98, no issues. You can able to manage this. Or now you just see that we have made it as 30. Okay, we have made this as 30 grade. So for 30 grade, what will be your corresponding permissible shear stress? You are supposed to check for 30. Okay, so Control F, table 19. Okay, table 19. Yes, so now I have to check for M30 grade of concrete with 100 AST as 0.20. Okay, so 0.25 with M30 as 0.37. Okay, so this will be 0.37, or you can take it as 0.4 only, right? So therefore here also your this is not permissible, but since it is one-way shear, okay, no issues. So therefore I am not changing any shorter dimension and longer dimension. So I am keeping as it is. I am making this as 3.2. Okay, and this I am going to make it as 4.8. Okay, 4.8, and the thickness 1.20, I can make it to 1.30, and spacing I can make it to 5 inches. Okay, spacing I can make it to 5 inches, right? Okay, so that is my second column. Then here when it comes, what are the things I am supposed to change? Supposed to change the critical section. So this is done. Yes, I can change critical sections like this. Okay, let's do one thing. So let us do the critical section, right? Okay, why it is coming negative? Yeah, sorry, I have not given the value. Correct. So now here 0.97 means again I will give. So let us give 1 meter only. Let's see what will happen. 1 meter, and let us give this as 1.5 meter. Okay, so these two. Okay, so 1.5. So now I will make the critical section from here to this value. Okay, you can see it is 0.64 only now. Okay, or if you want, if you check here, you can see it is taken this value. Okay, 0.64. Then this will be now my effective thickness, it is 171. So let us give minimum as 300. It should be minimum 300 value. So this one I have given, and this overall depth. Okay, done. Okay, even I have to change overall depth also. Was it changed here? Yeah. So overall depth, then everything will come here. Then this I am supposed to change to here, this I am supposed to change to here. So therefore automatically you can see my permissible is 1.3, it is 1.5. So not possible. I am supposed to change my footing thickness. Let us keep as it is. We will change the value of this. Let us make it to 1.2. Okay, now let us see what will happen. So 1.35, 1.5, because you know it is dependent on punching shear stress. yeah, punching shear stress. So this depends on this one, whereas this depends on again final thickness and column dimensions. Okay, so this also let us make it to thickness of 325. Okay, so then let us see what will happen. 3.37 1.4 it is coming because your column is of very smaller dimension. So it means we cannot provide that column here. So let us provide this column 0.30. So therefore when I provide a column of 0.30, then what will happen? We can see it is 1.37 1.4. okay, so 1.37 1.4 d1, let us make this as 1.3 itself. So now what will happen? 1.37 1.4, yes, so almost this is done. Okay, yeah, even it is safe from my the one way shear also, it is okay, it is almost, it is comparably, it is okay, right? So therefore I can give my this, again I have to change. Okay, yes, so if you check this, it is with respect to this one. Yeah, I have to make it to 2. This one. Yes, final shorter dimension. This one also I am supposed to make it to final longer dimension. Okay, yes, if you want you can bring this here also. Yeah, yeah, even I am supposed to change these two also, keep it in mind. And I think overall depth of the footing, no issues, it has been done with overall depth of the footing only. Okay, so therefore I can have 4.3 meter, I can have 5 meter, and I can have 1.3 and spacing as 6 inches. Okay, yes, so this will be my final values. Okay, yes, so after this, so when you go to, so therefore we have completed these 3 now. Okay, we have completed these 3, right? I can give 1 2 3. So I am supposed to do this now. So again, okay, so I can make it as, let's see, as 1.3 meter and this as 1.5 meter. Okay, yes, this one and this one, and I am supposed to change this critical section, right? So now I can give that 160, let us give 300. Okay, so anyhow it won't work, we can give 325 only, thickness 325. So this is my overall depth. Then I am supposed to change my A0 B0. Okay, I am supposed to change my A0 B0. So therefore you can see 1.37, it is 1.6. okay, so therefore what I will do here is, so I will change my column positions of 0.23 and 0.46, and even the load is also little heavy, I will increase my footing thickness from 325 to 350. Okay, so when I do that, yeah, 1 second, yes, now let us see what will happen. critical, okay, column. Yeah, so according to this, just a minute students. So how I calculate my A0 value, it is longer dimension of the column into 1000 plus effective depth by 1000. Okay, whereas this is shorter dimension of the column into 1000 plus effective depth by 1000. It means everything depends on the depth of concrete. Okay, so therefore what we can do is our everything will be decided based on the depth of concrete only. So therefore you can see that I have to increase my depth of the concrete. Okay, I have to increase my depth of the concrete. So as the final depth, let us keep it as 400 mm. Okay, so therefore 450, right? So now what will happen? It will be almost 1.4. okay, almost safe, right? So therefore, so this will be my final dimensions. So I can make this, I am supposed to change it to here, this I am supposed to change it to here, and overall depth it is done. So therefore I can give 4.3, 4.3, then 5, then 1.5, then spacing of 7 inch. Okay, spacing of 7 inch. Yes. Then when it comes to, so this is my 4. Now when it comes to this, again it is 600 only. Okay, so let us give 1.3, let us give 1.5. okay, then I have to keep this column, so I have to change the critical section. Okay, then let us give again 400, so I have to change this to 450. now it will be done. So this will be the spacing, everything will come. Now my punching shear I have to change here, this one. So therefore 1.37, 1.4. okay, almost okay, you can say that 1.37, 1.4 same only. So therefore I can give this the final value. Okay, here also I am supposed to change this one, this one. Okay, so same, so it is 4.3, then 5, then 1.5, then 8 inch. Okay, yes. So after this, this is for your column number, group number 5. Then this is group number 6. So the same thing, I will give 1.3 only, make 1.5 only here, here. Okay, yes. So then this let us maintain same. I have to change the critical section. Yes. Okay, then let us make again same 400 only, let us maintain, because column load, you know, it is heavy. Okay, so how much is the column load? 600. So let us make the same as 400. Okay, so let us keep the column dimension 400, and I have to drag this. Yes, so then your final punching shear, right? Okay, 1.37, 1.4. okay, no issues. So therefore I can go to my final again, same value I can give 4.3, then 5, then 1.5, then 6 inch spacing. Okay, yes, done. So that is my group number 6. So then next you have is group number 7 of 900 mm, right? So it means now let us give the value as 1.2 is there. I will give directly 1.5. I can make this as 2. Okay, so therefore here, then my critical section I have to change here. Then 230 is there, let us give the value as 500. Okay, let us give the value as 500. So this will be now 550 mm. Okay, then directly I have to go to this one. Okay, so you can see 1.37, 1.2 much more safer. Okay, so therefore I can give the same value here, right? Okay, so this one I am supposed to change. Right, so therefore I can make this as 5 feet, I can make this as 6.5, I can make this as 1.8, I can make it as 2 feet, this is as 5 inches. Okay, yes, so that will be your group number 7. Then 900 only, therefore I will give 1.5 and 2. Okay, the same dimension I will be maintaining, 1.5 and 2. Then critical sections I am supposed to change here, and let us make the same 500, and let us make this 550. This also I am supposed to change to this one. Therefore what will happen, so this is actually 1.37. okay, so I think this is grade 25, no, it is 30, yeah, 1.37, right? Yeah, which one I was doing? Yes, this one. Yeah, so you can see that it is 1.37, 1.2 safe, right? So therefore it is 5, 6.5, 2, 4. Okay, yes. Okay, done. So that is my column number 8, group number 8. Next you have group number 9. So it is 1.0, therefore let us make 1.3. okay, and let us make this as 1.6, so let us give 2 only, right? So therefore I'll change to this, then I'll change this color, then I have to change the critical section, right? So let us give again 500, and let us make this as 550. okay, then I have to change my punching shear values, right? So therefore when I check, it is 1.371, right? Very low value is there. It means you can increase your you can decrease your thickness of the footing from 500 to 450, and let us check what will happen to your punching shear. So 1.37, 1. okay, yes, okay, then what will be your this one, K20, yeah. So if I make it to 300, yeah, it is, you can go to 300 also, 1.37, 1.2. so therefore much more safer, 1.37, 1.2. Okay, 1.37, 1.2, much more safer. So therefore I can make it 300 only, it is more than sufficient, right? Okay, so then even I'm supposed to change this one, right? Okay, so therefore I can give 4.2 as 4.3, then 6.5, then 1.2 and 5 inches. Okay, yes, so that is about your column 9. Then next you have 700, so therefore I will maintain same 1.3 and 2. Okay, so then my critical section I am supposed to change here, changed. So let us give effective thickness as 300 only. Let's see what will happen. Yes, so this will be 300. So I have to change my A0 and this one. Therefore what will happen to this 1.37, 1.3 safe, so I can bring to this same. So therefore I can make 4.3, 6.5, 1.2, 4 inch. Okay, yeah, so that is my column 10. Finally I have column 11, right? The last column, it is column 11. So here it is 1.5, let us give, because it is 1.3, then let us give 2.2 meters. Okay, so let us try what will happen. This one, yes, so then I have to change the critical section. Okay, then you are getting the effective thickness 281, so let us give 300 and let's see what will happen. Okay, so 300, this I have to change, then I have to change this one also. Okay, yes, so 1.37, 1.7, right? You can see that the load is very large, so therefore better what you can do, you can make it to 1.5 and you can make this as 2.5. okay, you can make this as 2.5. so now immediately you can see that it comes to 1.4, right? So and you can little bit increase the thickness from 300 to 350 so that it becomes 400, and you can see that your permissible 1.3 and 1.37 almost safe now. Okay, so therefore I can give, I have to change this also, so therefore I can give 5 feet, I can give 8.5 or 8.3 I can make, and it is 1.31 means 1.4, and spacing it is 4 inch spacing, right? But you can see that 4 inch spacing I cannot give, you should always give the lower value. Therefore what I will do is I'll just increase my diameter of 12 mm is there, no, that I'll make it 10. So therefore now automatically, sorry, I'll make this as 12, it is 14 mm, right? When I do that, automatically your spacing becomes 5, so I can make it to 5 inches, right? So in this way now we have completed the design. So then what is my next step is, so we have to incorporate this. Okay, we have to incorporate this in the AutoCAD. Okay, we have to incorporate this in the AutoCAD, and we have to see that how the columns and beams are going to come for our plan. So that let us see in the next class. Okay, that let us see in the next class. So for example, if you want that to be anything to be inserted, so what we will do is we will insert some 3 to 4 columns. So that is shorter dimension, longer dimension, and finally the final depth. Okay, I can give 3. Okay, so I can give FINAL, final, SHORTER, final shorter dimension of footing, right, that will be in the meters. Then final longer dimension of the footing, that will be in the meters, and final thickness, THICKNESS, final thickness in mm. Okay, so if you want, what I can do, equals to, I can directly go to my final shorter dimension in meter, enter. Okay, so this is equal to my final longer dimension in meter, enter. So then next final thickness, that is overall depth in mm, equals, right. So the same thing what I can do, I can bring it till here. Okay, because using this only we are going to do it for the AutoCAD. Okay, yes, so let us see that in the next video. Okay, thank you learners. We will insert our footings and columns in the AutoCAD, and let us see that is there any overlapping. Okay, that we will see in the next video. Thank you learners.